So let's take a look at some of the questions. For the following graphs, determine the numerical values of the unspecified constants. I guess they mean A, B, and D. So if I take a quick read, what do I need? I need the maximum, which is 1, 2, 3, 3, and this one is -1, right? So A would be equal to the amplitude, remember? So what you do is you take the difference between the maximum and the minimum, which will be 3 plus 1 divided by 2, which will be equal to 4 divided by 2, which is equal to 2. Okay, so basically you're always looking for what's the center line? This is your A value. So I went from 1. 1 is going to be my center line, spoiler alert. But D is equal to maximum plus minimum divided by 2, which will be equal to 2 divided by 2, which will be equal to 1. Which means that this center line is at 1. Look at that. Lovely. Okay, last one is that dreaded B value. Now remember, B is equal to 360 degrees divided by the period. So let's figure out the period. That you can read off the graph, more or less. So again, for that one, maybe change color because it's exciting. So I'll start here. How far do I have to go before this whole thing repeats? So this starts to repeat right here. So how far did I move vertically? So this seems to say that this is 0, 30, 60, 90, 120. Seems to go to 120. So this will be equal to 360 degrees divided by 120 degrees, which will be equal to 3. That's what B is going to be equal to. So they didn't ask for this, but you may be asked for this. What's the equation? So the equation will be y equals 2 sine 3x plus 1. That's the equation of this thing, and you can actually put it on your calculator, check to see if it looks the same. Next, function has this form. The point A is a maximum, point B is a minimum. Use this information to find the values of A, B, and C. Exact same thing. So remember, this is your max, this is your min. Don't use the wrong numbers, right? So I'm actually going to leave this to you because I want to make this short as possible. Okay, so remember, use the maximums and minimums to find A and D, and then to find B, find out how far do you have to go before things start to repeat. Okay, and it looks like it seems to go from here to here before it starts to repeat, which I count as 1, 2, 3, 4. So that's 4, right? So it would be 360 divided by 4, which would be 90. So K would be 90 in this case. The other ones I'm just simply too lazy to find what A and B is. It's in your textbook and you can check the back. This function models the height above or below sea level of a part of a renewable energy generator. Given that y is measured in meters and x is time, interpret each of the values for A, B, and D. Okay, well again, I told you what these things are. So my interpretation of this would be it's the height above or below sea level. So this would be the average sea level. This would be the maximum displacement or height increase or height decrease or whatever you want to say from average sea level. And B, that one has to do with time, right? Remember? That is the number of what is x measured in minutes. Let me think about that because I'd rather think about period. It just makes a whole lot more sense to me. The period here is equal to, what did I read off for the period? 4, right? So I read off 4. That's how far you go before it starts to repeat. So t equals 4. So really, that's what I'd rather say, is that it's, although 4 doesn't make a lot of sense. But let me leave that alone for now. K equals or not K. That's the actual letter that we usually use. But your textbook decided to use B. B is equal to 360 divided by 4, which is equal to 90 degrees. What it means is in one... Unless we're using radians, this doesn't make a lot of sense. I'm kind of stuck on explaining that one because it doesn't make any sense in degrees. But I would say, what is B? Struggling with that. Okay, here's the best I can come up with. In 360 days, not degrees, days, believe it or not, there will be 90 cycles. Kind of stuck with that. I'm going to give that some thought and may revisit it the next lesson. This is the problem with working in degrees and not working in radians. Degrees has a unit involved with it, so I have to convert it from degrees to, in this case, minutes. Very, very annoying. Or not days, actually. I just noticed that. Minutes. In 360 minutes, there will be 90 cycles. Does that make any sense? Maybe that makes more sense. So you will have... It will take 4 minutes for one cycle. There you go. See, period makes sense. B doesn't really make any sense. Anyway, I'm babbling. I think I'm... Oh, wait, there's another one. Okay, same kind of thing. It's an application. So if you want to sketch this thing, personally, I would just shoot for the equation, but you can try to plot this out. This might be an interesting one for you guys to try, but I would go for minimum. They give a maximum. Our cosine. Well, it's cosine right here, so you're starting at a maximum. Okay, so what would this thing look like? Perhaps they do want me to just graph it. From what to what? From 0 to 15. 0 to 15. And let's chop that up. Notice that the minimum, there's a minimum at 2.5 and there's a minimum at 7.5. That's the time, because that's on the x-axis. So that means there's 5 hours. So it's 7.5 minus 2.5 equals 5. 5 hours between minimums. Okay? Which means that that's the period. If those are the minimums, that's what it should be. Okay? It's not quite right with tides, but okay, we'll let that go. I guess there's currents and all that stuff. So that's the period of repetition of this thing. So I would say I would chop this up into 3 nice and tidy little things like that. They say you hit a minimum at 5, so at -10, so I'll drop it. -10. You get a minimum at 5. No, at 2.5. And you get one at 7.5. So I assume there'll be another one 5 hours later. 12.5. Those are your minimums. The principal axis is at y equals 0. Okay, this helps, which means that the maximums will be kind of symmetrically at 10 above. Oh, why did I make this so big? So maximum here, the maximum here, right in between, maximum here, and I suppose I can finish off the maximum here. Ooh, this is going to be a fun graph to graph. I made the y scale a little aggressive. There you go. That's what it looks like. Determine the values for R and S in Pam's model. So R is like A, the amplitude. Well, the amplitude is, what I see here is 10. So R equals 10. And S is, for us, it's going to be 360 divided by what is the period here? By the period, which is 360 divided by 5. That's how long it takes to repeat. So if we do that, that's divided by 5, that's 72. So there you go. Okay. So S is going to be 72. So this would be done by f of x equals 10 cosine 72x. That's because we're working in degrees. There you go. I didn't calculate D because they don't have one. It's not in their model. Anyway, I'm quitting there.